Section 2.3 is about polynomial and synthetic division. So we're going to add another tool to our toolbox to help us solve polynomial equations, and we're going to use division. We've done this before in the past in Algebra 2, but it's been a bit since we've done it, so let's refresh ourselves on it. So we're asked to divide 6x to the third minus 19x squared plus 16x minus 4 by the factor of x minus 2 using long division, and then use the result to factor the polynomial even more. So we're going to set up the long division. So we're going to set up the 6x to the third minus 19x squared plus 16x minus 4, and we're dividing that by x minus 2. So if you remember back to Algebra 2 when we did this, we kind of focus on just that first piece there. That minus 2 is going to come along for the ride, but we're really going to focus on that x piece first. So I'm going to say x times what gives us that 6x cubed, and that's going to be 6x squared. In other words, what's 6x cubed divided by x? So I'm going to take this whole group and multiply by 6x squared. So x times 6x squared gives us 6x to the third. Negative 2 times 6x squared gives us negative 12x squared. Now, just like what we do with numerical long division, we're going to subtract those two lines. So 6x to the third minus 6x to the third cancels out. That's the whole point. Then we're going to do negative 19x squared minus negative 12x squared. So in other words, it's kind of like plus 12x squared, which gives us negative 7x squared. Now we're going to bring down this 16x, and then we're going to repeat the process. Now we're focusing on the x and the negative 7x squared here. So x times what gives us negative 7x squared? That's just negative 7x. So we're going to multiply all of x minus 2 by negative 7x. So x times negative 7x gives us negative 7x squared. Negative 2 times negative 7x gives us plus 14x. And just like we did at the previous one, we're going to subtract that line. Sorry, my arrow got kind of in the way there. So we're going to subtract negative 7x squared and 14x from the other group. So negative 7x squared minus negative 7x squared cancels out. 16x minus 14x gives us 2x. And now we're going to bring down that last negative 4. So now we're going to say x times this 2x, or x times what gives us that 2x, or 2x divided by x gives us 2. So we're going to take all of x minus 2 and multiply it by 2. So x times 2 is 2x. Negative 2 times 2 gives us negative 4. And we'll subtract these two lines, and we end up with 0, which is good because that's our remainder. So what we end up with, we kind of just factored out the x minus 2 from that function. What we're left with is 6x squared minus 7x plus 2. Because remember, division and factoring are very, very, very closely related. When you're factoring out something, like you're factoring out x minus 2, it's as if you were dividing it out from that original polynomial. Now it asks us to factor this out completely. So we've already factored out x minus 2, but this group right here is a little more complicated. Now I'm going to set this up. It's going to be similar to what we've done in the past with the quadratics. We got the first two numbers to have to multiply to 6x squared. And when we multiply 2x times 3x, it's going to give us 6x squared. These two blanks are a little more complicated, but thankfully not too complicated. They're going to need to multiply to positive 2. But when we do this number times this number, so the 2x times that second number plus this number times this number, they have to add to that negative 7x. Thankfully, there's not a whole lot of options. So when we try these out, so we have to think of two numbers multiplied to give us positive 2. That's either 1 and 2 or negative 1 and negative 2. If we try negative 1 and negative 2, when we go through and do 2x times negative 1, that gives us negative 2x. Oh my goodness, I wrote the, sorry, I wrote negative 1, I meant to write negative 2. So if we do 2x times negative 2, that gives us negative 4x. Negative 1 times 3x gives us negative 3x. So negative 4x and then negative 3x gives us that negative 7x we're looking for in the middle there. Okay, so that's as factor as we can get. Now, example 2, sometimes you're going to get a remainder. This past example, we got no remainder, which was nice. But unfortunately, that's not always going to be the case. So sometimes you end up with a remainder. In that case, we got to put it over the divisor. In other words, what we're dividing by as an added fraction at the end of your answer. So for example, let's try out this one, x squared plus 3x plus 5. We're dividing it by x plus 1, setting it up the same way we did the last one. So we have x squared plus 3x plus 5 divided by x plus 1. So again, focusing on that x there. X times what's going to give us that first x squared? That's x. So let's multiply this whole thing times x. X times x is x squared. 1 times x is x. And we're going to subtract these two lines. X squared minus x squared is x squared. 3x minus that x gives us 2x. We'll bring down that 5. Then we repeat the process. X times what gives us that now 2x, so that's plus 2. So we have this whole thing times 2. X times 2 is 2x. 1 times 2 is 2. And we'll subtract, and we end up with 2x minus 2x, which is 0. 5 minus 2 is 3. Now we ask ourselves, x times what gives us 3? And we're kind of stuck. So that is our remainder. So what we're going to do is we're going to take this x plus 2, then we're going to say plus 3 divided by that divisor of x plus 1. Let me give you a side example of why this works out this way. If you were to do, say, 29 divided by 7. If we do this long division style, we would do 29 and 7. We'd say, how many times does 7 go into 29? It goes into it 4 times nicely. And we do the 28 down there, and we subtract, and we end up with 1, and that's our remainder. So we would say it's 4, and we'd say like plus 1/7, or we would just say 4 1/7. So that's the easiest way to do it numerically. That's what we do with the remainder in our polynomial division as well.